Hey geometry students, this is Mrs. LaGrew. I had to reshoot this video because the first one for some reason was too long and YouTube deleted it. So here's the first video for trigonometric ratios. And the first thing that we're going to talk about is what is trigonometry. Trigonometry is a study of triangle measurement. And what that means is that we use it to find side lengths of a right triangle with any angle, or we use it to find angle measures inside of a right triangle, okay? So the first thing that we're going to talk about is what are trigonometric ratios? Well, there's three specific trigonometric ratios that we're going to focus on here. And the first one is sine, and then we have cosine, and thirdly we have tangent, right? And there's this acronym that you can use in order to help you remember what these ratios are. Some old hippie caught another hippie tripping on acid. I know it sounds a little funny. Whenever I teach this in the classroom, people laugh or they're astonished as to the fact that I just said tripping on acid. But it's a funny way to remember the three ratios. So some old hippie refers to the sine ratio, which is calculated with using the opposite side over the hypotenuse. Cosine, the part of the sentence is caught another hippie. A represents adjacent, H represents hypotenuse. For tangent, in the sentence that's tripping on acid, the O represents opposite and the A represents adjacent. And let's talk a little bit more closely about what we mean when we're referring to opposite, adjacent, and hypotenuse. Up until now, we have been looking at right triangles, right? And obviously they always have a right angle in them. And in every single one of these right triangles, we've always referred to the angle, anytime that you have a 90-degree angle, the side across from it is called your hypotenuse, right? So I'm going to abbreviate hypotenuse, or I'm going to use the letter H to represent it. And in the ratios, the letter H is referring to the hypotenuse. Now, whenever we are referring to the trig ratios, we can have angles other than 30, 60, 90, and 45, 45, 90, which are the special right triangles that we talked about last week. So, and we're going to call this theoretical angle theta, right? So I'm going to put a theta here. And theta could just represent any angle. When we are given a right triangle with an angle, right, when we look at the side across from that angle, then we call that the opposite side, or abbreviate OPP for opposite, or just use the letter O to represent opposite. And when we have the angle and a side length next to the angle, right, we call that the adjacent side, or abbreviated ADJ, or just plainly using the letter A. Okay, so hypotenuse always across from the 90-degree angle, opposite directly across or in front of the angle, and then adjacent, the side that happens to be right next to the angle. But don't get it confused with the hypotenuse, okay? Remember, the hypotenuse is always the longest side and always across from the 90. That's one of the mistakes that people will make. All right, so let's take a look at a type of question that we would have to deal with this kind of a problem. Okay, so in this problem, I have this triangle. It's a right triangle. It has two of the side lengths and it's missing one. Let's backtrack a little bit. Usually, you'll have a right triangle, and I'm just going to call this 3, 4, 5, and that's one of the most common Pythagorean triples, right? So I'm just going to use that, and then I'm going to call this theta, right? And I'm going to find sine of theta. So I'm going to pay attention to where theta is, which is right here, and I'm going to look directly across from that. And remember, anytime that an angle has a side length across from it, we call that the opposite side. if the side length is next to it, we call that the adjacent. And the one that is directly across from the 90, we call that the hypotenuse, right? So let's remember, some old hippie is what we use for sine theta. So that old hippie is opposite over hypotenuse. So when we set up this ratio, this is going to be 4/5. Pretty simple, right? That's the easiest thing that we could be asked to do, is to just find the sine value for angle theta, which is 4/5. We could also be asked to find the ratio for cosine theta, right? And remember, cot another hippie, that means that we have adjacent over hypotenuse. And we're still using the same numbers in the same place because theta is still in the same location. So 3/5 would be the answer to cosine theta. And then finally, we would calculate tangent theta, tripping on acid. So opposite over adjacent, which means that we're dealing with the ratio 4/3. Okay, so these would be the three trigonometric ratios for theta for this specific triangle. And notice, in this triangle, I gave you all three side lengths. But then sometimes I may only give you two side lengths, like in this example. We have the legs 9 and 12, right? Specifically, we're referring to angle W, so we're talking about this angle. But we need to know what the hypotenuse is. So what could be used to find the hypotenuse? Pythagorean theorem. So we're going to plug it in. It's going to be 9 squared plus 12 squared equals c squared, right? We know that 9 times 9 is 81, and 12 times 12 is 144. And then we're going to set it equal to c squared. When we add 81 plus 144, we get, I believe, 225 plus 81. Yep, 225. Okay, so c squared is equal to 225, and we have to isolate the c by getting rid of the square. So we take the square root of both sides, and when we take the square root of that, we get that c equals 15. So the hypotenuse has a value of 15, okay? Now that we know all three side lengths, we want to label each one of the sides with an O, an A, and an H. Since the 15 is directly across from the 90, then obviously the 15 represents our hypotenuse, right? And then we notice that the 9 is right next to the angle, so then that's going to be labeled A for adjacent. And then directly across from angle W is 12, so 12 will be our O. And then all we need to recall is some old hippie caught another hippie tripping on acid. So sine of W is going to be referring to some old hippie. So that is our O over our H. Oops, let me write that a little bit nicer. O over H. So in this case, that means that we're talking about 12 over 15. And we notice that 12 over 15 is not in its lowest term, so we're going to reduce that by 3. And when you reduce it, that becomes 4/5. Okay, then we have cosine of W, caught another hippie. So that's referring to A over H. And A over H in this case is 9 over 15, which can also be reduced by 3. And this fraction will become 3/5. So then we have tangent of W, tripping on acid. So tripping on acid refers to opposite over adjacent. And in this case, that means that we have 12 over 9. And when reduced here, we get 4/3. So these are our ratios for sine, cosine, and tangent of W. All right. Now, when you are asked to use trig ratios, sometimes you're given an example like what you see on the screen now, right? I've given you two sides. I've given you a angle in the problem, and you're asked to find side lengths using trig ratios. Trig is a short way to refer to trigonometry. Okay, so in this specifically, we're going to have to use calculators. If you have them, make sure that your calculator is in degree mode. All right. I have a scientific calculator that I'm using. Normally in the class I use a graphing calculator, but since I don't have that here, I'm going to go ahead and use my scientific calculator. The degree is right here next to the second. And so I'm going to press that first to make sure that when I solve my problems, everything is in degree mode. All right. In this problem, we're going to pay attention to the angle. The angle is 28 degrees. And then we're going to label each one of the sides that's given. X is across from the 28. So in here, the X will represent our opposite side. Then we're going to notice that the 90 has a side length of 19 across from it. So that means that 19 represents our H, or the hypotenuse in this case. When we see O and H, we think of some old hippie. So some old hippie, remember, refers to sine of theta. Sine of theta equals O over H, right? So when I substitute into this problem, my theta is 28. So we're going to have sine of 28 degrees equals X over 19. Now, in this video, we're going to be focusing on trig ratios when X is at the top of the fraction. In the next video, we'll focus when X is at the bottom of the fraction. And in the last video, we'll talk about how to find the values of the angles, okay? So this problem is very simple to solve. You're trying to get the X by itself. Notice that the X is being divided by 19. So think of, how do you undo division? Yes, multiplication. So since we're dividing X by 19, we're going to multiply both sides by 19. Okay, so we're going to show that. Times 19 to both sides. On the right side, the 19s are simplified to just give you X, and then we have 19 sine of 28 degrees. Okay, now, if you don't have a calculator at home, it's okay. Don't freak out about it. You can leave your final answer as X equals 19 sine of 28, and I'll accept it because guess what? That's the actual answer, right? When you plug in 19 sine of 28 into the calculator, it actually gives you an approximate answer. So when I plug that in, 19 sine of 28 gives me 8.919. So I'm going to write X is approximately 919 will be my approximate answer. Okay. But again, if you have no calculator, leave it as 19 sine of 28. If you do, go ahead and simplify it, 8.919. If you just want to be safe, you can give me both answers, all right? Here's another example. So here again, two given sides, one given angle. We're going to pay attention to where the angle is. Label the given sides. The 8 happens to be next to the 55, so that means that 8 represents our A. The X is directly across from the 55, so that means that it represents our O. So anytime that we have O and A, we're dealing with tripping on acid, so that means that we're referring to tangent. In this case, the angle is 55, so we're going to put tan 55 equals opposite, which is X, over adjacent, which is 8, okay? Like before, X is being divided by a number, here specifically the number 8. So to get the X by itself, we're going to multiply both sides by 8. Okay, so let's do that. 8, 8, 8 simplify, we get X, bring it down. We have 8, 10 of 55. Remember, if you don't have a calculator, I'll accept this as your final answer. If you do have a calculator, you can find the value. That value is approximately 11.425. Okay, there you go. Pretty simple. Let's try another example. So here we've done a sine example, a tangent example, and now we're going to see a cosine example. We have the angle of 21. The side next to the X, remember, is our A, and the side directly across from the 90 is our hypotenuse. So caught another hippie is a part of the acronym we're gonna use here. So we're gonna set up cosine of 21 equals X over 26. And like before, when we have a number being divided into the X, we're going to multiply both sides of the equation by that number. So here in this case, we're going to multiply both sides by 26. Okay. 26 are simplifying to just give you x, and then we get 26 cosine of 21 equal to x. So x, if you don't have a calculator, the actual answer would be 26 cosine of 21. Or if you do have a calculator, you can go ahead and find the actual answer, which will be x is, great, thank you, honey, 24.273 will be the approximate answer. Hold on, baby, go take it downstairs. Okay, so let's do one last example, which is the word problem. Let me see. Take it downstairs, please. Take it downstairs. We have here a word problem. Jake leaned a 12-foot ladder against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? Excuse my son. He wants to be in the room while I'm recording. So let me go ahead and draw the right triangle. Yes, he's obsessed with Pac-Man right now. So there is a ladder leaning, the house is here. Okay, there's this house, the ladder is here, there's a 12-foot ladder. The angle is being formed with the ladder and the ground, so 68 degrees goes here. They've also told us, let's see, how far from the base of the house did he place the ladder? So that means that the X is down in the bottom. So after we draw the picture in a word problem, that's the first thing you're going to do is draw the picture. Then you're going to identify where the angle is, label the given sides. In this case, the A is the adjacent side. The 12 is the hypotenuse. So then after you've labeled, identify what you have. We have adjacent and hypotenuse. So that means that we're dealing with another hippie. So we're going to use cosine of 68 and set it equal to x over 12. Okay, to get x by itself, we're going to multiply by 12 to both sides. And the 12s are going to simplify, and we're going to get x equal 12 cosine of 68 degrees. And this would be our exact answer. But if we plug it into the calculator, we're going to get an approximate answer, and that approximate answer is going to be approximately 4.495, and the units in this problem, that will be feet, okay? This is the end of my video. I hope that this time you're able to view it, and if you have any questions, just let me know. Have a great weekend.